Hey guys, this is lesson 4.6, exponential and logarithmic equations. And so we're going to start with example 1, which is solving an exponential equation with a common base. And so what I want you to notice about this problem is that both sides are base 2 and then have some things in the exponent. And so if they're base 2, it should be common sense with an equation where one side, whatever's on that side, equals another side, that if their bases are the same, those exponents have to be the same. So I'm going to say x minus 1 has to equal 2x minus 4. And so we solve this equation. I'm going to subtract x. So I have negative 1 will equal x minus 4. Then I'm going to add 4. These are going to cancel. X is going to equal 3. And so you'll notice if you plug 3 back in, you do get the same thing on both sides, so it is equal, and 3 is your answer. Okay, for our next example, we're going to have a similar situation, except the bases will be different, but they're kind of related. Okay, so what you want to do is think about the 8 and the 16 as powers of some number. Now, immediately we jump to like 4. 4 times 2 is 8 and 4 times 4 is 16, but we're not trying to do that. We're trying to think of them as powers of something. So the next thing I'm going to think about is 2, because 2 cubed is 8 and 2 to the 4th is 16. So I'm going to rewrite this as 2 cubed. And when you do that, you want to put whatever's in the exponent in parentheses because you'll end up distributing. And then I'm going to write 16 as 2 to the 4th. And again, put whatever's in that exponent in parentheses. And now you can think of it like we were thinking of that first problem. It's an equation, they have to balance, and if both sides have base 2, their exponents have to be equal. So I'm going to say 3 times x plus 2 has to equal 4 times x plus 1. And then I'm going to distribute. So I'm going to get 3x plus 6 equals 4x plus 4. And I'm just solving an equation from there on out. So subtract 3x. I get 6 equals x plus 4. Subtract 4. And x will equal 2. And again, if you plug it back in, you'll notice you do get the same thing on both sides. So I have that answer there. Okay, so for example 3, we are going to do something similar, but we may have fractional exponent. So if you look at our example, we have 2 to the 5x equals the square root of 2. And so what you want to think of is, how can I write that square root as an exponent? And we've done that several times in the past few days. It is the 1/2 power. So on the left, I'm going to have 2 to the 5x. And on the right, I'm going to say 2 to the 1/2 power. And so again, I have that same situation, and again it happens to be a 2, but both sides have the same base, so their exponents have to be equal. So 5x will equal 1/2. And then to get rid of the 5, I'm going to divide both sides. And 1/2 divided by 5, you're basically going to multiply the 5 and the 2 and get 1/10. You can think of that as that keep, change the sign, and then flip 5. So that's how I'm doing it in my head. But again, this is my answer because it gives me the same thing when I plug it back in on each side. Okay, so example 4 has the equation 3 to the x plus 1 equals negative 2. And these are different bases this time, so this one is a little bit different. And what we're going to look at here is how you could graphically solve this. And I have the graph down here, but just as a reminder, how you could get this in your calculator is I would plug like the left side into y1 and the right side into y2, and you would be looking at this graph. Now, we also talked in this chapter about what the graph of 3 to the x plus 1 looks like. It is your exponential function. It has been moved left 1. But if you remember, there is a horizontal asymptote here at 0 that this thing is not going to cross. So I even knew before I looked at the graph that it was never going to be negative 2 because the exponential graph here hasn't been moved up or down, so its range is from 0 to infinity. So I knew before I even looked at the graph they weren't going to cross. But that is one way to check yourself or to solve equations that maybe you aren't really sure about how to work with. Put one side in y1, the other side in y2, and look at the graph. And again, since these did not cross, they are never equal. So this is a no solution situation. Okay, solving exponential equations using logarithms. So this is probably more like what you've done in your previous math classes because the bases are different and I can't make them look the same. 5 and 4 are not some number to a power and that being the same number. So it's not as simple as those first couple of examples. When you have this, what we are going to do is log both sides. Now you can log or you can natural log. I would say either one would work in this case. If this had an e in it, I would go with the natural log. But I'm just going to go with a regular log to show you this one. And when I say log both sides, I mean literally put a log in front of your two things. Now, if you remember from our properties of logs lesson, you have exponents here that can move to the front using that power rule. Now, this x plus 2, I'm going to put a parentheses around it, but I am going to move it to the front. I'm also going to move the x to the front over here. Alright, and so you can keep them in log form or you can turn them into decimals. And just for simplicity's sake, I'm going to turn them into decimals, and I like to keep at least 3 or 4 decimal places just to keep things fairly correct as we go along. Okay, so log 5 is actually 0.69897 and it continues. So I'm going to just use about 4 decimals there, and I'm going to say it is 0.6989. And log 4 is 0.6020. And the reason I like to do that is because we are so used to solving equations. You guys sometimes get confused when I have those logs in there, but you got to remember it just stands for a decimal. And so if you just had this equation and it was a number, it's much easier to see that you just need to distribute it. So I need to do 0.6989 times x and 0.6989 times 2. So I get 0.6989x plus 1.3978. And then over here I have 0.6020 times x. And so it's an equation. It's an ugly equation, but it's like every other one that you work. You're trying to get your x's together, so I'm going to subtract the 0.6989x so that my x's are both over here. That's going to leave me with the 1.3978 and give me negative 0.0969x. And then my last step would be to divide by that. And so x is going to equal whatever I get when I divide these. And so that is negative 14.425. Now, getting a negative kind of makes me question everything, so because I'm wondering, so I'm just double checking all my math here, and I think I have it right. You can check your answer again by just typing in the left side, seeing what you get, typing in the right side, seeing what you get up here. So I'll do that, and then we'll move to the next problem. Okay, so it does check out, and that is our answer. Okay, so example 6 is similar to our last one, but this one has an e in it. So for sure this time, instead of regular log, I'm going to use a natural log. So I'm going to do the same thing. I'm going to natural log both sides. Natural log of 100. Actually, let's go back. I could have made that simpler. So I could have started out by dividing by 20, which would probably been the best bet there, because it gets us down to the e and gives us some smaller numbers. So 100 divided by 20 is 5, and I have 5 equals e to the 2t. Now if I natural log both sides, a lot more manageable. And when you do that, you actually have the choice of looking at it like we did the last problem, which you could move that exponent to the front, or as some of you like to do, you can look at it as canceling out, because the natural log of e is 1. So 1 times whatever is whatever, or 1 to whatever power is 1. But your log rules move that exponent down when that happens. So I'm going to look at it like that, and that side's just going to become 2t. And again, I'm going to get the decimal form of that natural log 5. So 1.6094. And then I'm going to divide by 2. So that's going to give me 0.8047. Okay, so our next example is similar to the last one, except we have more stuff to get rid of first. So I want to get this e part by itself. I'm going to subtract 5 from both sides. And so 12 minus 5 will be 7. And then I'm going to divide by 4. So I have e to the 2x equals 7/4. And so again, to get to that exponent where the variable's in it, I'm going to have to natural log both sides. So natural log e to the 2x will equal natural log of 7/4. And again, I can look at it as moving that exponent to the front, and then the natural log in e being 1, or some of you just cancel out there. But either way you think of it, you get a 2x on that side. And then I'm going to have the natural log of 7/4 as 0.5596. And then I'm going to divide both sides by 2. So my x is going to equal 0.2798. Okay, so here is one for you to try. I want you to pause now and try this on your own. Okay, so let's check your work and see how you did. So the first thing about this one is it had e's on both sides, and so you needed to get those together. So that was kind of a little twist compared to what we have done. But if you subtract this e to the 2t on both sides, you get 7 minus 1 basically on this side, and so that will be 6 e to the 2t. You still have the 3 on this side, and so you want to get the e by itself now. Divide by 6. And so you'll just be left with the e to the 2t here, but then 3/6 is going to reduce to 1/2 on the left. Then you natural log both sides, so you get natural log 1/2 and then natural log e to the 2t, and then however you view it, the natural log and the e go away, so you get 2t equals this decimal, negative 0.6931, which is the same as natural log 1/2. Then you divide by 2, and t ends up to be negative 0.3465. So how did you do? Okay, so this one is going to be a little bit different. This one, if you look at the title there, it says solving exponential functions in quadratic form. So quadratic, you're immediately thinking, you know, factoring and the quadratic formula and stuff like that. But this thing has e's in it. So why are they saying this? Well, if you look at the exponents, you have e to the 2x and then e to the x. So those can't be combined like we combined in the last problem. I'm going to make it look like a quadratic by subtracting 56. And so I have e to the 2x minus e to the x minus 56 equals 0. Now, if I had given you x squared minus x minus 56, what would you have done with it? Well, I would have probably tried to factor, and if I didn't factor, I would have used the quadratic formula. So the question is, does this factor? And again, these are basically the same thing, except where I have x's over here, I have e to the x's over here. So I'll get back to that in a second. Let's worry about the 56 and the negative 1. So I'm going to factor the way I factor. I'm going to say 1 times negative 56 is negative 56. And then I'm trying to get a negative 1. So what's going to multiply to give me a negative 56 that adds to give me a negative 1? So that'll be 8 and 7, and the 8 will have to be negative so that when you add them, it'll be a negative 1. So if I was factoring this over here, it would factor to x minus 8 and x plus 7. But what I have is e's. So where the x's are, I'm going to have e to the x. So e to the x minus 8 and e to the x plus 7. Now, again, some of you are bothered probably by the fact that this is a 2x here and we don't have 2's here. But remember, when you multiply things, you add the exponents. Just like over here, this started with an x squared, but in the parentheses we have x's. The powers get reduced when you're factoring. Okay, but if I were to multiply this back out, my e to the x times e to the x would be e to the 2x because I would add those exponents together. So I have correctly factored this now, and I'm going to do what I would do normally and set each one of those equal to 0. So I have two little equations. And I'll just have to solve those. So e to the x equals 8. And then I'm going to natural log both sides. That's going to cancel. So x is the natural log of 8. Or if you get that in decimal form, 2.079. For the second one, we would subtract the 7. And again, I immediately know that this is not going to work. Now, if you continued on and you tried to put the natural log of negative 7 in your calculator, you would get an error. This part is not going to give us a solution because your e to the x graph is always positive. Its range is everything above 0. And negative 7 is down here. So those are two graphs that are not going to cross. So that's not going to give us an answer. Our only answer is the natural log of 8 or 2.079. However they have it written if it's a multiple choice situation in your work. I don't care if you stop if it's something simple like natural log of 8. If you just leave it natural log of 8, that doesn't bother me. But if you like decimals, you can turn it into a decimal. Okay, so now I have another one that I want you to try. So this one I think is like a quadratic as well. So work on this one. Pause. Okay, so let's check your answer. Again, it's sort of like a quadratic. So I wanted to get everything over here with this e to the 2x. So I'm going to subtract the e to the x and subtract the 2 from both sides. So it ends up e to the 2x minus e to the x minus 2 equals 0. Then I factored that to e to the x minus 2 and e to the x plus 1. When I solve the first one, I get the natural log of 2 as my answer, or whatever that decimal is. And when you solve the second one, it doesn't actually work because those graphs are never going to cross. So the second one does not give you an answer. How did you do? Okay, so that was all of our exponential equations. Now we're going to move on to log equations. And I'm going to teach you the same kind of method with each one of these. You always want to get your natural log or log by itself first. So in example 9, we need to get rid of the 3 and the 2 first. So I'm going to subtract 3. So I get 2 natural log of x equals 4. And then I'm going to divide by 2. So I have the natural log of x equals 2. At this point, you want to change to exponential form. So you think about your base and your exponent and your answer. So I'm not doing magic here. I'm changing to exponential form, which is what we did a couple of sections ago. So my base is e, my exponent is 2, my answer is x. And so sometimes you'll find it written just as e squared. Other times you'll have the decimal version, which is 7.389. But actually, either one could be there. But again, change to exponential form. That is the big thing to remember when working log equations. Okay, so on example 10, I have a similar situation. I want to get this natural log part by itself. Now it does have a more complicated x, but you can't do anything about that until after you've changed forms. So the 2 is the only thing I can get rid of right now. And I end up with natural log of 6x equals 7/2, or you could put 3.5. And at that point, that is the natural log by itself. Change it to exponential form. So the base is e, the exponent is 7/2, and the answer is 6x. So I could divide by 6 and say like 1/6 e to the 7/2. I'm going to get the decimal in this case though, just because I think it would be easier to work with. So e to the 7/2 is 33.115. And then I can just divide that by 6. And so 33.115 divided by 6 is 5.519. So here's another one for you to try. Try number 10. Solve 2 natural log x plus 1 equals 10. So pause. Okay, so we'll check your answer. First you had to get the natural log by itself, so you divided by 2. Gave you a 5 over here. Then you changed to exponential form, so e to the 5th equals x plus 1. And I decided this time to just go ahead and subtract the 1. So I could either have e to the 5th minus 1, or I could type that in and get the decimal, which would be 147.413. Okay, so for this example, I just want to go over graphically solving one more time. This is a log example. If you were going to get this graph over here the way they did, they put the natural log graph in y1, and then they put y equals 3 in y2. So they just typed a 3 in y2. And it would give you this graph. And where they cross, this 20.08553, this would be the solution to this equation. So if you were to solve this out by hand by saying e to the 3rd equals x, you would get 20.0855. And so it's another way to solve that equation, and that's the point of this here. This is a really good technique. Although this is simple and something you can solve by hand, this is a really good technique if you're ever on a standardized test and you have an equation that you cannot remember how to solve or can't figure out how to solve. You put one side in y1, the other side in y2, and find the intersection. That solves the equation for you. Alright, the last type of equation we're going to look at is one that has natural log on both sides. So if we have natural log on both sides, the way that we can get rid of it is by e'ing both sides. In other words, raising those two exponents on e's. Okay? Or you can look at it like we did those original problems where we had the bases of 2. Both of these are natural log of something and they're equal to each other, so their insides have to be equal. But most of you like to cancel out e's and natural logs, so if you e both sides, it will cancel your natural logs. That's probably the way that you're going to think of it. And that will leave you with x squared will equal 2x plus 3. But again, if you think about the insides having to be equal because it is an equation, you get to the same place. Now, this obviously is a quadratic, so I'm going to get it all equal to 0. So I'm going to subtract the 2x and the 3. It's going to equal 0, and then I'm going to factor again. So my kind of factoring, I would have a -3, trying to get a -2. So that would be 3 and 1, but the 3 would have to be negative. So I have x minus 3, x plus 1, and then I have little equations when I separate those. Now, the one thing with log equations, you always want to check your answers because you cannot take the log of a negative number. So if I plug these back in, what's inside the parentheses needs to be positive. So 3 squared is 9, that's positive, that's good. 2 times 3 plus 3, that's positive, that's good. If I plug in -1, I get a positive 1 because I'm squaring it. I would get a -2 here, but once I add the 3, I would get a positive 1. So both of those are good answers. You do occasionally get ones that when you plug them back in, you have the natural log of something negative, and that answer has to be thrown out. So that concludes the lesson for this section, and if you have any questions, make sure that you answer or ask them the next time we are together face-to-face in class.